Good afternoon, everyone, and welcome to Layer by Layer, the show about 3D printing and our place inside the industry. Today we're going to talk about 3D printed shoes, 3D printed traps, and how Tangled is going spoolless, and then why being cheap also forces you to be good. But before that, let's go ahead and pay the bills. This episode is brought to you by Tangled Filament, tangledfilament.com. This is our attempt to drive the cost of filament down to $10 a spool. We're doing this by improving the efficiency of the process and focusing really hard on just driving down the cost. We started out at $22 a spool, and now we're sitting down at $15, and we're working to continue to push that down even further. Right now, you can get any color filament you want, so long as it's black and so long as it's PLA. So go ahead and get yourself a couple spools today. Tangled Filament is available, and right now it is shipping immediately. For the very first time, we're caught up. So do get it. It'll ship very quickly now. And I do apologize to everybody in the past. It's been tough staying caught up with it. But thank you all so much for the support on that. We'll come back to that a little bit later, though. First in the news. Zellerfeld has been developing a cutting-edge 3D printing technology to redefine... hang on just a minute here. A little editorial here. Zellerfeld has released open signups for designers to submit shoes through their website to then be printed and distributed. Zellerfeld was originally established in 2015. First of all, let's put a pin in that for just a moment. Well, actually, not a pin in that. Let's shine a spotlight on that. That's the analogy I want. 9 years. This is 9 years since the company got started. I knew Cornelius, the CEO of Zellerfeld. We originally met in 2018, when they were still messing around with their first pair of shoes or so and really working to refine it all. Right now, they are deploying print farms, and they've just released effectively their API and print-on-demand system so that designers all over the world can upload shoes to them and have them be printed. And congratulations, guys. Good work. We need more of this. But this is great because, yes, now the barriers to entry of designing a shoe are now fairly dropped. Zellerfeld has a lead time issue still, and they have a little bit of a business model issue because right now what they're doing is, okay, designers can sign up through their, effectively their dashboard, and they can submit their shoe design. They can then go through kind of the Zellerfeld process of getting a shoe design approved to be used with their process, which is the right thing to do. Keeps them focused, make sure the stuff that comes through is good and that goes out is good. But from the purchasing side, right now what they're offering is you're able to purchase a manufacturing slot for $10. When that manufacturing slot comes down, when your shoes will be made, and what shoes will be made is a little bit ambiguous right now. I messed around with their new site recently, and I was not able to locate the shoes that I was able to purchase. I was able to purchase a manufacturing slot, but they notify you when your slot comes up, and then you pick your shoes. Not a fan of that. To be fair, I'm not a big sneakerhead, but as a product guy, not a fan of that. But it's a way to get the system up and allow them to estimate demand so that they can know how many machines they need to get built here. They raised about $10 million about 2 years ago now, have been using that to ramp, and their partnerships with like Heron Preston and that kind of stuff have allowed them to scale. And Zellerfeld is one of the better 3D printing companies for remaining focused on a very particular application. So good for them, and I'm glad they've been able to open it up to other designers. There's some implications to that may or may not be good, but I think it's the right step, and I wish them the best. So that was great. Framework has released an open source 3D CAD files for its Laptop 16, allowing user-driven customization for owners of the machine. Known for its modular laptops, Framework makes modular laptops. Everybody watching this podcast knows who Framework is already. The company has also unveiled a new version of their Laptop 13 featuring Intel. Yeah. I'm sorry, guys. There's just more information that I know a lot of you just don't care about. Due to high demand, the larger Laptop 16 is now back in stock and available for immediate shipping. Yes, great. Framework laptops are back in stock. But the CAD files are on GitHub. And by the way, Comment down below if there's like a framework accessory that you'd like to have us build, because I've been wanting to do something with framework for a while, both on the channel and as a product through like Tangled or something, or 3D model. I don't know what to make because I don't know what 3D printed wedge we can stick into one of the slots that would be useful. I personally would want to do something like handles or something along those lines, something to be, or like guards or bumpers, or I don't know what all, which again, shouldn't be plugged into the slots on the side. But what's an accessory for a framework laptop that you'd want? I don't know, a cup holder. Again, not a great idea, but something there. Give us some info and some ideas of what you think would be there. But yeah, framework is fully open sourced, effectively, the CAD models for their laptop. So you can now create some new accessories for it. And I think we should get that done. They have had these models out for a while. This isn't like real new news. They've been doing this for about a year now. But yeah, let us know what you think we ought to do. Alrighty. Jose Francisco Ortega Arlcon has developed 3D printed beehives to support sustainable farming. Using resin 3D printing to create the hexagonal structures, eliminating the bees' need to construct hives themselves. This approach allows bees to focus on honey production and plant pollination. Traditional hive construction relies on beeswax and natural secretions, which are time-consuming to produce. While beekeepers use hive boxes to enhance honey production, the bee population is going down. These 3D printed hives present an alternative by preforming the hexagonal structures, thus reducing bee labor and mitigating fatigue, heat, noise, and space issues common in conventional hives. So, I didn't know this. I didn't know that hives weren't like pre-laid out with the hexagonal structures inside of there. I presumed that it was fairly common. I don't know much about bees, to be fair. I know the population's going down. That's all I know. I'm an amateur. The 3D printing the hives, I think, is a good idea. It's a reasonably complex structure. It is something that could be extruded if people wanted to scale it up. But bee farming really is not that big of an industry. Even though it's really important, it's really tough to scale up. You're moving around between fields and that kind of stuff. So printing, and particularly like our scale of 3D printing, might be a really good way of producing it. I would hope that this student is trying to design these hive in structures to be kind of a vase mode style, which they're probably not, but it would radically improve the manufacturability of it, and provides the value that you need there. He's using resin. Resin is an expensive way of doing it. FDM would be faster, better, cheaper. So I recommend all those. I didn't mean to like start giving design tips on it all, but I would recommend vase mode, using like a PLA, even if it's hot outside, it doesn't really matter. Well, beehives get pretty darn warm on the inside. Go for PETG, you'll be fine. And then go from there. But this is a great application because, beehives are not a super high volume type of item. Get those designed that way, and that would be really helpful. And I'm glad that I didn't know that the bees would accept preformed structures. I thought they went and built their own honeycomb themselves. But if they'll just go to town, laying honey inside of an existing structure, good on you. That's a great thing. University may receive government funding for ongoing research. Mexico's rich bee biodiversity supports an annual production of over 60,000 tons of honey, benefiting more than 43,000 beekeepers. So each beekeeper produces about 1.5 tons of honey. That's a lot of honey for a single person. Like, imagine a pallet of honey from a dude. Yeah, that's a lot of honey. But anyway, all right, good stuff. 3D printed traps aid in tracking invasive species in Ontario, Canada. A pilot project has employed 3D printed traps to monitor the spread of the hemlock woolly adelgid in Ontario. The HWA, the woolly adelgid, a small insect that kills hemlock trees by extracting fluids from twigs, has been detected in Halmond, but not yet in Brant County. This is too specific. I gotta work on our show notes. President of the Brantwood Woodlot Owners Association is utilizing these tracks to check the presence of the adelgid. This initiative is part of a collaboration between Natural Resource Canada, yada yada. Adelgid. I'm going to keep on using the word adelgid. Adelgid is a good bug name, by golly. But yeah, they're 3D printed traps. They look like little discs and they have like sticky slides on top of them. We've actually done this with a few clients. We've had a number of universities and bee tracking, not bee tracking projects, like bug tracking projects. These greenhouses and other sorts of applications are really good. Again, they're kind of this mid-volume sort of thing where they need a few thousand of them and a mold doesn't make sense and they'll change the design. So these research projects are another great application of 3D printed parts because they can take advantage of all sorts of different benefits. So yeah, great to see that. And it enables these tools that otherwise wouldn't exist because 3D printing is a technology that is now approachable, whereas like injection molding is not. So you can imagine someone creating a product with 3D printing and then scaling it up more easily than you can imagine someone creating an injection molded part and scaling it up, because the manufacturing of a molded part is a big, complex, woolly, and expensive monster. So anyway. Alrighty then, moving on to company updates. All right, Tangled. Like I said, we got it all caught up. Orders should be shipping very fast right now. We're in cadence. We're past the bursts. We've done all the things. We're going to get to this. We're going to slow burn here, make sure that we're nailing it all. The filament is good. You guys are loving it. Thank you so much. Now we're going to be in a little bit of an optimization mode where we're going to try to take everything that we've got, make sure that it's all running smooth, do the final tweaks on stuff, tighten down the bolts, so on and so forth. Make sure that we're continuing to refine. The next little refinements, we got to make a tweak to packaging because right now most of them are shipping in 9x9x9 boxes. We're going to change that to an 8x8x9 box, which is a little bit more expensive per box, but it does allow us to reduce the wear inside the boxes because we are having some, we're still having some spools wear through the vacuum seal and shipping. So we're going to mess with boxes one more time and then that will be nailed down and then packaging will be nailed down. We have spools fixed right now. We had an instance the last couple of weeks where we have been short on spools, which is why we have been a little bit slow to ship stuff. But we got spools in, and we now have the supply chain cadence for that to make sure that, it takes 3 weeks to get them loaded up over here. So we'll plan ahead that far, which is kind of a cash flow problem, but it's one we can deal with. Because those spools create a cash flow problem, you have a bunch of stupid money sitting on a pallet doing nothing that cannot do anything else. Like we cannot use a 1 kilogram spool anywhere else inside the business. It is a complete lockup of liquidity. And in a business, you don't want that. When we buy pellets of like PLA and that kind of stuff, we can turn that into filament that is either sold or used in our factory. So it has multiple uses and we can turn that into cash again in case you ever get in a hard spot. Can't do nothing with the spools because no one's going to buy empty 3D printing spools from you. Believe me, we've tried. Anyhow, going spoolless so that this disappears as a problem. We just bought the first machine for making spoolless filament. This is experimental because quite frankly, the documentation about spoolless filament doesn't exist. The manufacturers who do it right now are all not in the USA. And the manufacturers inside of the States who are doing it, I don't want to use it as an example for reasons. So we're effectively recreating it. We found a machine that serves as a baseline. We're going to do our own modification with it and that kind of thing. But that machine is being made and will be delivered over the next 6 weeks or so. So we should be able to try that. By the way, side note to anybody out there starting a business, or a manufacturing operation, there is a machine for every task that you have to do. There is a real human need to be like, this can't be done or whatever else it was. No, probably can. If you're a new small business, probably everything that you're doing can be done automatically through some sort of mechanism. And you just have to find that mechanism and figure out how to word it, which means that you just have to steep yourself in the industry to where TikTok is recommending you weird machines. Like, that's the thing you got to do. We recently got a hold of a machine that is being put into our post-processing station that I knew about, but I only knew about it in the context of a different industry, and I didn't realize how it applied to us until we were looking at a different project around coffee. And then this machine came to my attention. I was like, oh my gosh, this is the thing we need over here. So the cross-pollination and just the realization that very few people have original ideas, and therefore anything that you think is an unsolved problem probably has already been solved. Like, very likely. until you get really deep into an industry. Then you can start seeing problems that are like bleeding edge. But if you have just started up, you are not the smartest person in the room. Go find the stuff you need. You don't need to build it. Oh, this was the other thing. I saw a company, a well-established company. I'm not going to name them here. Everybody watching the show knows this company. This company had a machine that they built custom for sorting out screws, which I know for a fact they could have purchased more cheaply and had operate more reliably if they just bought that machine. But they built it themselves kind of out of arrogance and out of kind of a makerish attitude, which is ending up hurting them because they wasted time and resources building a machine as a vanity project, as an engineering project. And that's okay to a limited degree, but you're operating a business and you have to get to the point of getting your job done first. And sorting your screws in the back is not something that any of your customers care about. So do it with whatever machine is handiest. Sorry, I apologize. I didn't mean to get that to a rant, but yes, the machines you need are out there. Literally, you'd be amazed how complex of an operation can be done with machinery. There's very few that are not. Don't have some stamper, automated, whatever else it was, jig thing that can do whatever you need it done. So there's the simple things from wire stripping all the way up to screw sorting and so on and so forth, counting all of this stuff can be done. So if you're a college student and you're going into an engineering job or something like that and you see somebody doing anything by hand, just describe what they're doing by hand and Google it for like an hour. And you probably will find the machine that will do it. And then your boss will be super impressed when you say, you should use this machine over here to save us a bunch of time. And he'll be like, good job, new guy. And you'll be promoted and you can thank me later. All right, Tangled, Spooless. Yes, we got a Spooless machine coming. PETG. We are starting the first stages of getting PETG production into Tangled for y'all. PETG, of course, is a little bit hairier material because it's hygroscopic. I'm not going to talk about all of it there, but it's not going to be your mother's PETG. So with Tangled, we started with PLA because PLA is low effort as an extrusion medium. Like you don't have to worry about a lot of processing. It's pretty forgiving. You guys can all print it, so on and so forth. With PETG introduces a number of complications, so we might as well just double them up. We're going to do some special stuff with PETG to where it's going to be very good PETG. Like it's going to be really good PETG. At the same time, also being cheaper than PLA. So it's going to be a lot of fun. It's going to be a nasty ramp because there's some dirty secret that's going to stick us in the face. But I think you guys will really, really like the PETG. It'll be spoolless. Oh yeah, FYI on the spoolless. The spoolless will become the default. We may continue to have normal 1 kg spools, but spoolless will be the default. Of course, we will have a spool that you guys can print, and of course, it will be compatible with AMS and all those things. Like we will do all the things that need to be done, but spoolless will be required. And if you want to use it, you're going to have to print yourself a spool. But all that being said, it shouldn't be a big hassle. And again, with the machinery we've got, it should be very reliable, very nice, very pretty, all the things. But yeah, PETG is coming down. The PETG is going to be sick. Yeah, and that's kind of Tangled. Tangled, we should have also Gray coming presently. I'm not going to commit ourselves to a date on that yet. That's in production schedules. We're messing with things. But yeah, Gray should be coming down. All right. API upgrades. The API is stable. Of course, we introduced Moon Rocks last week. And of course, red and yellow have become available now through Etsy and the API. Those are all good. You guys have been eating those up. Seem to be working all right. Glad you enjoy them. Other than that, it's holding up. It's stable. You guys are moving a lot of files through it. So we're cracking through a number of milestones more quickly than we thought we would. So thank you all for that. And we're making sure that we're keeping the systems monitored and scaled. As per usual, if you run into a problem, please let us know. We don't always see the problems because we have to know the problem would exist before we put in the test for that particular problem. We can put in the things about things that we know about, but if there's random whatever, please just let us know. We literally put a bug report button at the bottom of every page of like the Etsy and all the rest of them. So let us use it, please. We really, really appreciate that stuff. And quite frankly, we generally have a stipend for people with bug reports to where we, thank you. We really want to thank you there. Okay, let's see here. All right, this is an announcement. We've mentioned this before when we started the whole API project, but we have started work on the Shopify plugin. And the Shopify plugin will effectively do what the Etsy plugin does, but for Shopify. So for all of you with Shopify stores and wanting to get off of the Etsy platform and that kind of thing, that option will become available. Shopify is a son of a gun to work with. They are, some of you may have developed apps for like Apple before, or even Google Play. Google's reasonably stringent anymore, but Apple's very stringent. I think Shopify's more stringent. The rules around the development of a Shopify application are many and specific. So we're working through all of that, but we're looking to have a Shopify plugin beta available fairly soon. Weeks, not months. That's what we're looking at right now. Do let us know. It will be a very similar version to the Etsy. So I think there's still lots of room for other applications similar to this that can utilize it in all kinds of different ways. So just let us know, and let us know any way we can help. We work with just let us know features that you would want to see in that, and we will either pass them on to other people who are working with the API, or maybe try to implement them. But like we're also very stringent and focused about what we're going to do with any one of these components. Okay, Shopify, the first beta of the Shopify will not have catalog attached to it. That, again, in the context of staying focused on what we're doing, that feature probably will not make it into initial release. But the catalog is over on Etsy, and the catalog is going to start getting a large upgrade over the next few months because we're going to start building out catalog with a lot of new files. More on that in future. All right, discussion topic. Cheap breeds quality. So, if you go to engineering school or you work in product, you will very often be told about the triangle of options. I actually don't know what it's called. You can have it fast, you can have it cheap, or you can have it good. You can have two of those, you don't get all three. And I've always frickin' hated this metric, this idea, this premise, this heuristic, because it's bullshit. Pardon my French. It creates an excuse for average mean level work. And this I was running through this because I was running through the Starship just recently launched. Their launch 4 went by the other way, and if you haven't seen it, I recommend it. They landed the thing. But when I was going into that rabbit hole, I was reading up on the Raptor engine. And the Raptor engine is the main engine used on Starship. There's 38 of them on that vehicle. The Raptor engine in 2021 cost about $2 million to make a piece. And that was not sustainable for anything that SpaceX wanted to do with Starship, and certainly was not acceptable to Elon. But what the spec became was they had to get it down to $200,000 to build one of those Raptor engines. 200,000 times 38. Still expensive, but given the fact that the Starship is bigger than the Saturn V, and the Saturn V cost $1 billion in 1960 monies, pretty good. So the spec became 200,000. And what was interesting about that is that even though the Raptor has become cheaper to manufacture, right now I think they've hit the spec, or on their next generation they're going to hit that spec for sure, of $200,000 per engine. Even though it's become cheaper, it has gotten better, objectively better. The quality and the reliability of it has improved. And the reason for that is because in order to make it cheaper, they're removing parts and components. They're aggregating them, they're deleting them, they're deciding what's important, and if it's not important, they get rid of it. Systems that are redundant, they get rid of it. Now, Generally, quality is defined by either the labor put into it, the reliability of the thing, the allure of the thing, or the craftsmanship within the thing. So like Hermes is appreciated because of the craftsmanship and the story. A Rolex is appreciated both for its reliability and, again, its craftsmanship. And then utility, like Apple has kind of the brand relationship, but it's also has product benefit from it. So it's like a comfortable phone to use that works with everything, works with other Apple products. So that generally is what defines quality, either craftsmanship or extreme utility. The way you get extreme utility, most people think most extreme utility comes from feature sets. That is wrong. A Swiss Army knife is not higher quality or a better object than an Hermes Birkin bag. Arguably worse. So quality has to do with, does it perform its function better or worse than what a more expensive option does? Generally, if you get something cheaper, you presume that it does the job worse. And even, again, in school when I was coming up, we were told, never say you make it cheaper, say you're making it more affordable. Cheap sounds cheap. However, again, going back to the Raptor engine, the Raptor engine has become cheaper, but better. They did it by eliminating redundancy, and the only way you eliminate redundancy is by improving reliability in the main system. The way you improve reliability of a system is you eliminate things that can break. So you reduce the part count. But by reducing the part count to improve the reliability, you decrease the cost to make the thing. So it creates this really weird circle where to improve reliability, you delete parts, but by deleting parts, you make it cheaper. So that you go back to improve reliability, improve quality, you reduce the number of parts, and it gets cheaper. Also, as you go through this idea of quality, you're able to establish what is actually necessary inside of a product and understand what is necessary. Everybody refers to this as first principles. That's fine. It is first principles. Like the block of steel costs a couple $100. Why does the machined part cost $13,000? Well, because we are machining this part. There's only 2 guys on the planet who know how to machine this part, so they have to be paid $13,000 an hour. Okay. So in order to decrease the cost, we have to reduce the amount of machining that those guys do. By reducing the amount of machining that those guys do, we make the part cheaper. We don't hurt its reliability. And in fact, we might think a thought like, oh, let's not machine it at all. Let's go look at this other process. This is something that applies to like the Tesla Model 3. The Tesla Model 3 front and rear end were both about 80 to 100 parts for the set. So the front end was 88 parts. And then they said, well, we've been sticking, gluing, screwing, and welding these parts together, these 88 separate parts. In order to get to good quality, it's almost impossible because each one of those joins creates an instability, a tolerance problem that then propagates throughout the front end until you have a crooked front end. How about we take all those parts and just shoot them as once as a gigacasting? Now we have one part that's perfect every single time. And by the way, we're just shooting in aluminum, so it's just the cost of aluminum. There's no machining, there's no gluing, there's no labor down this trail. We improved the quality and made it cheaper. I haven't been able to define this algorithm or this relationship in this, except to know that it's true. And I think it's really just to be very extreme about it. To say, no, you cannot allow the budget to go over. Figure it out. Another story on this, around the trio. You can have it fast, cheap, or good. In college, about 10 years ago, I was in my machine design course. The professor who'd been teaching it had been teaching this course for about 20 years. And at the end of each semester, he would assign to teams of students to build a winch. And I think we were given a budget of like $50 for each team to buy the parts. And the whole point of this exercise was to prove you could either build this winch strong, you could build this winch fast, or you could build this winch affordably. And there were prizes for each one of those categories. And the presumption and history of this class was that no one could ever win all three. There was another one for precision. Like, did your math play out in the real thing? You could become precise if you bought expensive parts. You could be strong if you did really high gearing, but then you would lose precision. And you could be low cost if you made the stuff yourself, but then again, you lose precision and so on and so forth. I don't like losing all three categories. So I decided we weren't going to. What I did in my team, I went to my team and I said, we're going to win all three. Or all four of the prizes, or all the categories. We're just going to make a perfect winch. And they're like, you can't do that. It's possible. I went down to the machine shop and I grabbed a piece of plywood. And I said, guys, look, we can make our own gears. And we will do it out of this chunk of plywood because in order to be the strongest, this plywood will be fine. I can make gears well by just using a bandsaw competently. So we'll have the precision and we won't have to buy expensive gears. So we'll have the cheapest, the fastest, the strongest, and the most precise. The precise I was wrong on. Somebody else did put in a worm gear, so they were like points. They had like multiple decimal places of accuracy, so they did win on that. But the other three that were generally interchangeable, not spoilers on, but we did pretty well. I ended up carving out several gears, and my team from the very start said no to this. When I pitched it, like, let's carve gears out of plywood, they said, no, plywood's not strong enough. And I was like, what, why? And they're like, plywood's not strong enough. It's not for gears. I was like, I think it's fine. And they said, nah, we can't use plywood. We're going to go this direction. So they all started designing it. And I said, look, guys, I'm going to make a gear. I'm just going to prove to you that this works fine. So that afternoon, I made a gear, and then I filmed a video of me beating it against a brick wall until it broke. And I said, does this seem strong enough to you? Do you think any part of the winch that we're going to make is going to be strong enough for you? That convinced them because beating it against the brick wall, I dented it a bit, but I didn't break it. But it was a good demonstration of what it could do. So all of that still did not convince any of them. At that point, I was mainly just being the dick in the group and saying we're going to build it like this. And all the rest of you are busy with senior project, so I'm going to build this. So I did. I carved out these gears and we Gorilla Glued them to the spindle. We take it to the class, and we were the last ones to go. Everybody else, you had the guys who bought the gears, you had the guys who built the gears, all the things, you had pulleys and all the rest of it. Pulleys, you're dumb, you never want to use those for a gearbox or a winch. But went through all the teams, did all the recordings, everybody saw what they lifted. They got to us. Every team lifted their max weight until they bottomed it out, and they timed it out. We had not tested this thing yet. We had not actually run it doing anything. But we knew it spun, but we didn't really know how much it could lift. We put like a 25-pound weight on the bottom of it, and we fire it up, and it goes clack, 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 clack. It sounds like some old Da Vinci rotary monster, but it just raises its weight like it's nothing. Yeah. So we go ahead and we put like 50 pounds on it. Clack, 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 takes it on up there. We keep on going. We run out of plate weights to lift with this thing. We never maxed it out. We ended up trying to drag a couple of guys across the ground. They never maxed it out. The professor who is judging this whole thing is like, I've never had this happen before. Never had this happen before. Because we were the strongest. We built it for $10, and it was also very precise and fast. But we ended up running all three categories, long story short. I still have the gear on my desk to remind me that in any given engineering situation, you get to have your cake and eat it too. There is almost nothing impossible to create. You may have to wait for a particular piece of technology to arrive. Like it's tough to do what SpaceX is doing right now if they did not have microchips. Vacuum tubes are tough to make light. Though at the same time, The Saturn V was launched with memory that was sewn together. So there's always a way of getting done what you need to get done, exactly as you need it done. This is one of the joys of engineering and why it's so much fun. The art of creation is that you get to do whatever you want. And so long as you do not constrain yourself by what is allowed, or especially by what other people are doing, you can do whatever you want. For example, the Raptor engine. Rocket engines are expensive to make, period. Until you just decide that they're not going to be, and you make that one of the driving functions. You constrain the crap out of a thing and say you need it fast and you need it cheap, and you end up figuring out a way to get it done. Good people will end up figuring out a way to get it done. And as you put in those constraints, they start to feed off of each other. Again, making an object simpler makes it more reliable, reduces the steps, which makes it lower cost. So making it simpler to make it more reliable makes it lower cost. So there's very often these constraints of like quality and low cost complement each other. And we're seeing these things in like Tangled too. Spooless. Spools create a lot of administrative work, not additional labor, but identical amount of labor. And they add cost to the product because we have to pay to make them and then we have to ship them to you, which is weight and so on and so forth. But by eliminating spools, we improve the product for you so long as we do it right. We have to do it right. But we reduce the cost for us, which reduces the cost to you, and it improves the quality of the product because there's now no longer the waste. And it feeds off of itself. And we're going to be doing and we do a similar thing inside of the spooling and all the rest of this. It's like, okay, well, what do people want? What do they need? How can we do that? Okay, we need to make it cheaper. We need to eliminate that, which then actually improves it and makes it cheaper. So, the end of the story with the gear, we broke records. We broke all kinds of records. And we broke that project because the professor had to make a rule the next time around that you were not allowed to build your own gears because we broke the format of the class, the lessons that were supposed to be learned, that you have to trade off things once in a while. And once in a while you have to trade off things, but not very often. The next semester, he told this story to his class. The reason I know this is because, number one, I was the teaching assistant in the class the next semester, and number two, because several of the students came back to me and said, Gabe, we heard about what you guys did last year. I was like, yeah, I know, I bet you did. It's hanging up there above the machine shop. You can still see it. But what was interesting to me, very often the very best solutions end up being radically obvious once they're proven. I had to fight against my team to use wooden gears. The next semester, when everybody told me the story of like, oh, we heard that you used wooden gears last year, Gabe. We were going to do that. Too bad you beat us to it. I was like, and I kind of smiled and nodded because he'd done this class for 20 years. And no one had ever done it before. I really doubt that the class the next semester all had the same idea until after they were told it and heard how great it worked. But yeah, the lesson from that is that you can have your cake and eat it too. Engineering is very flexible. And very often, if you're not able to find the solution that you're looking for to get done what you want to get done, you don't have a broad enough education or solution set to pull from. Because there have been a lot of problems solved in humanity. And I would say that most of the problems that even we face right now are already solved. We just don't want to implement them. Because all of this stuff is 99% perspiration and 1% inspiration. Everybody has a great idea. Lots of people have the great idea. Lots of people write it down. Very few implement it. But there are those who have. And there have been a lot of humans who have lived. So if you have a brilliant idea for a thing, number one, go see if somebody else has done it. And if you have something that you can't solve, look other places to see what other people have done. And do not get hung up on if it could never have been done before. The world changes. Technology evolves. Things improve. You can very often invent something today that was not possible a couple of years ago. And very often, you don't even need to wait for technology to catch up. You can just get it done. We landed on the moon in the 70s, and I think we have better technology today, and yet we're still not on the moon. So I don't think that capability or technology is really the restrictor. It's just if somebody's tough enough to go do it. So toughen up and go do it. Have a great day, everybody.